Welcome, everybody. We're going to be working on the Unit 6 subquery assignment here tonight. And we're told right off the bat to use a particular database. So I'm going to go ahead into um, my MySQL workbench here. My SQL server is running in the background locally on my machine. And I still have all my files open from last week when we were doing summary queries, but this time we're doing subqueries, which are a little bit different. Last week, we were using the classic models database. And this week, we will be using the My Guitar Shop database. Now, you may have already loaded this one up, right? And so this might already be in your schema table because I think we have played with it before, albeit briefly. But if for any reason you don't have that database loaded up, you can come over to the, I'm trying to find it here, the resources, course resources sidebar menu item. And there is a file here you can download, which is just I'm going to go ahead and just grab it and then just show you its contents, right? And we've looked at this before, so I know this is, I'm going to say relatively redundant here, but we can look at it here. Let's use Notepad++ to take a look. But it basically removes the database if you already have it, creates the database, uses it, creates all the tables, inserts all the data, and you have a database that's ready to use. Now, I've already done that process, so I'm not going to repeat it. But just in case you haven't, maybe you're on a different machine or something, you can do that. Now, we were just talking about instead of using MySQL Workbench, if you were using, for example, PHP My Admin in a web browser, you could upload that SQL file to the web browser or to the web server. It's a different process than what we do here locally, and then execute the SQL file and do the same thing on a remote server. That's totally, completely feasible. I'm just throwing that out there. Since I have the Guitar Shop database already loaded up here, I'm just going to kind of open up the schema table here and just kind of take a little bit of a look and just look at the stuff inside here, what tables I'm dealing with, and what kind of data they contain. So it looks like I have about 6 or 7 tables here. So you have one with addresses, right? You can see the columns here, the administrators, passwords, names, categories, the customer table, the order items, the actual orders, and then the products, right? And all the details about the whole structure of it. If it helps you, and I'm just throwing it out there, especially if you're new to working with a database or if it's been a while since you've worked with a database, I don't think it's unreasonable to do things like goofy things, and you might think this is goofy. I kind of don't, where you just look, okay, what's in there? Okay, all right, I got it. Okay, what's in this one? And I would like systematically, if I hadn't touched a database in a while or never touched it, I would go through and I would look at all the data tables and try to figure out what's in them, why it's in there, how it's all arranged. And I would also pay special attention to these, the foreign keys and how the tables are connected. We will at some point look at some tools that are both built into this product and others that create what we call entity relationship diagrams that show how tables are connected together visually. It's not really pertinent right now, but that I think that's a really useful piece of information to look at as well in working with a database. All right. So now that I'm, basically familiar with most of it, right? Let's just say. Now I'm going to go back and I'm going to look at the instructions here in the core shell for what we need to do, and we are working on subqueries. So our first directive here, and maybe I should just go right to the document and download it and open it, which is what I suggest you guys do. One of the reasons why we do it like this is because this often will have examples of what the output will look like, so you know that you're doing the right thing. That's the one reason it's helpful. Do you have to have this? No, you could. It's the same query definition, both in the document and here, if you notice. All right, so I'm going to get ready now to do my coding, and I'm going to get this out of the way because I do not need it. I'm suffering from the way too many windows open at the same time phenomenon, which I know you guys can relate to. That's what happens when you've been doing it all day long. And I'm going to go one instruction at a time here. And for those of you that are here in the class, maybe you can do a little bit of a refresh here because I'm going to, you know, bring up a brand new query window. So I'm going to create a new SQL tab here. And because I know I'm working on this database, I'm going to issue, for starters, a use statement. So I'm going to say use my guitar shop. So that's the database that all my subsequent commands will execute from. And then I'll run that. And now you can see, I don't know if you guys picked up on that, but when I hit it, now that one is highlighted in the schema table because that's the one that's actively going to receive all the commands, right? And it's got a bold indicator here. And, just to kind of prove the point, right? So if I did use classic models, right, and I execute that one, watch the schema table on the left, notice how it switches, right? So I'm going to switch it back and run it again, and then reattach to the guitar shop, which is where I want to be. I'm going to just leave that one up at the top. We have a series of exercises to go through. And so I'm going to use some comments here, and we'll work on number one first. And I'll copy the instruction over so that I don't have to keep flipping back and forth, basically, between screens. And yeah, it's getting a little bit long there. So let's go like this with it. Right, so it's just coming in here as a comment, and it's on my screen so I can look at it, right? It says create a query displaying the category name of only those items that can be found in the products table. Okay, so some of the information we need is just given right off the bat. So in other words, we are looking for the category name. That's ultimately what we're trying to pull back of only those items that can be found in the products table. So I think we need to look at the data to understand what we're even querying. So here's the categories table, and that basically just has a category ID and then what category. And this is a guitar shop database, so it's got basses, drums, guitars, and keyboards. So we have four different categories. So that's a category name. And that's in the categories table. Okay, so that's one of the things that we're looking for. But we don't want to pull all the category names back. We just want only of those items that can be found in the products table. So now I'm looking at the products table also. So here's the products table, just kind of dumped out here, and you can see the product ID, category ID, a product code, name, description, price, and the date added. And this is going to be now the column that's going to basically link us right over to the other table. So if I look at the products table structure, category ID, right, matches category ID here. Here it's a primary key. Here it does not seem to be enforced as a foreign key. At least it's not indicated as one. But I think maybe there's a nomenclature here that if it's bold, that means it's an ID in a different table, right? So even though it doesn't say like FK here, that's our clue. So I want basically the category name of anything that exists here. And then I want you to notice, right? So this is why I'm looking at it in advance, that I have basses, drums, guitars, and keyboards, categories 1 through 4. But when I look at the product, I don't have anything in category 4. So it should pull back all of these, correct? Okay, oh, in principle, right? Like if we do a query that was generic, yeah, that would do it. Um, so we're going to start writing the outer query first. So here comes the outer query. So I'm going to say select the category name from the categories table. Right? You can do aliasing if you wish, but I'm not going to do that. Then our selection criteria is where the category and that was a underscore ID, where the category ID is in this query result. So I'm putting in parentheses and then putting a semicolon at the end, and then I split the parentheses. And the reason I do it like that is so I don't forget to close them later, basically. And so my subquery will go in here, and now we're going to do a fresh query, where think of it like that. In this case, we're going to select the category ID, but this time from the products table. So in other words, we're going to look in the products table, pull all the category IDs. It's going to pull back whatever it has. And as long as we have results here, any results, right? So, yeah, do the results exist? Are they in there? And are they any of those, right? So that's why those three words are kind of all in a simultaneous. That if we get any results, which we know we will because we've looked at the data, it should give us the name of all the categories. And I'm just noticing my spelling error here. Which we've already identified that'll be all the categories except for category number 4, which is keyboards, because we have no keyboards in our product list. So let's run this and see if that indeed happens. And here comes the selective run. All right, and here's the output. And notice indeed that our output excludes the keyboards. Now I could, for example, throw in a keyboard product, and then that should appear too. And I could come up with new categories, once again, with new products, and those would appear as well. But if I could create a category, for example, maybe I would create a category for sheet music or something like that. And until I actually stock some sheet music, it won't appear in this query. But this is our first example of a subquery. Everybody okay with this one? All right. Did anybody write this query already and use different keywords? Somebody use exists perhaps instead, or any? All right. Just to kind of do a little bit of an example here, I'm going to use the exists keywords, and I want you to notice that it flags, right? And to use this correctly, I have to get away from that column qualifier there. So this is going to be a similar result. And I'm just doing this as an alternative to show you that there's a difference in the output. And this might not be what you want, right? Because in this case, it's showing us all the categories. So there is a difference in which one you use, right? So I try to lump them all in as kind of being equivalent, but in essence, not, because we are saying, if it exists, show it, is different than if it exists in this list, and the product also has it, right? So that there's a distinction, and it really kind of shows the nuance of the query and why you can get different results. All right, let's move on to number 2. So I'm just going to mark this one here, number 2. Once again, I'm going to go grab the instructions here. And for number 2, it says create a query displaying the product name brought all the HTML junk with it, right? That's okay. I'm just commenting it out one line at a time. And I think that's all of it. Yeah, I think that is. Okay. So create a query displaying the product name and list price for the products. Use a subquery where the list price is greater than the average product list price display in descending order. So a lot more nuance here. Once again, I'm going to say that it's probably important to examine your data and take a look at what your data structure is and where you might find stuff. So because of the nuance of what they're saying here. So I'm just going to start building this, and I'm going to start with the outer statement first, and I'm just going to do a select. And they want to see the product name and list price. Well, that's pretty easy. Those both come from the products table if you take a look. And so there's product name and then list price. Those come from the products table. All right, so now comes the where clause where we're going to put our subquery. But we want to pull back only stuff where the list price is greater than that other criteria. So I'm just going to type that part first. I'm going to say list price greater than. And then I'm going to write my subquery, and I'm opening and closing my parentheses right away on purpose. And I could do this on two separate lines, but I think it's going to be short enough I can do it on one line. So that's going to be my tactic here. So I'm going to say select. All right, it says the average product list price. So normally I would type list price, right? But I want the average of it. So I'm going to use the average function, which is just AVG, and a set of parentheses around the parameter that we're feeding to it. And that's going to also come from the products table. So that's a complete query. So this is going to go in there. It's going to average the list prices. And wherever the list price is greater than what the calculated average is, then that's the data that we're going to pull. All right. We're also told to list it in descending order, right? So it says, or how you would do that is order by. Yes, order by. And what are we ordering by? List price, because that's what we're displaying, basically, and descending order. So the highest price items will be listed first. That would be the complete query. If you wanted to just get the average list price, you could just run that query and it would tell you. Right. So here's kind of an interesting thought, though, right? So if I write this is a complete statement, and just be mindful of the fact I'm going to separate it and just paste it here. And this is kind of weird. Why are you doing that? Well, I want to see what the average is the why. So I'm just going to run this statement standalone, right? And I can see that the average list price is $841.90. Basically, that would round to. So normally I would round that, but let's just call it $841.90, right, is the average list price. And so I can run that standalone just to get that value if you're curious, right? Because otherwise you're not going to know what that value is. You see the thinking? So that's the kind of thing you might choose to do. So now that I know that this outputs, and we'll write it here, 841.895 or 841.90, really rounded. Right, that's the average list price. Okay, let's go ahead and run this query now, and let's see if it actually brings back those products. So here's the run, and then we have, all right, so we have a Gibson SG for $25.17 and a Gibson Les Paul for $1,200, basically. Can we confirm it? Yeah, we can take a hard look at the data. The whole point of running the query, though, is not to have to, right? But there you go, right there. Now notice, if you run this query, that these two high ticket price items really skew the average quite a bit, right? And that most guitars are under $1,000, but you have some really nice ones that cost some real money. Right? And that changes it. So those are the two that cost above average out of all those products and their list price. Okay. So that's the output for that one. So we'll call that one done and complete. You guys okay on that one, or any questions? All right, good. Let's move on to number 3. So let's just make a little placeholder here to paste it in. And back over to the instructions. I have a little hint there as well, if you guys are catching that. All right, so number 3 says, write a query that displays only those category names that are not in the products table. Hint, subquery should use where not exists. Okay, so let's use that as a hint, and we'll try to follow that hint. And I know we talked about in and not in, and not exists is basically the negation of exists. And if it's helpful for you, and I'm throwing it out there, right? If you don't remember like the stuff that we were just looking at it, right? The exists operator is used to test for the existence of any record in a subquery. So any record in the subquery. It returns true if the subquery returns one or more records. So I just have to get one hit on an exists. Now, if I'm looking for a not exists, I'm looking for the inverse. Not that it's there, but it's not there. Right? You feel that? Right. Okay. Hopefully you do. Or if you're nodding and smiling, you're like, yeah, okay, whatever. All right. Let's start to write this one. So I'm going to do a select here. And we only want to see the category name here. So we're going to say category underscore name. That's going to come from the category table. If you want to do an alias, and I know like I've been like not doing the aliasing, but I'm just telling you, like, if you do a lot of queries and big queries with a lot very verbose titles, you probably want to alias stuff, you know. I just want to use the letter C to alias it. So we're going to use the suggested statement where not exists. Except you got to spell it right. There you go. And then we'll do our open and close parens. And what I'm going to do this time is I'm going to move those down a line. And then I'm also going to put in my closing semicolon so I don't forget, basically. And then I will compose my query here in place, right? So this is a format some people might use as well. That's why I'm kind of demonstrating it. So we'll do another select statement here. And now what are we selecting? We're looking for something that doesn't exist, right? So we want to see everything. So that'll be a wildcard. So we're just going to select everything from products. And what are we looking for? Where the category ID in the products table equals the category ID in the category table, right? And I want to be sure that I'm naming it correctly because I think I'm misnaming something here. So for example, that's not correct, right? Because the table name is actually categories. I'm surprised it's not underlining, but you know what? I could have ran it and we could have traced it down. But so the category name from the categories table, and we only want to select the products from the products table when the category ID equals from the products table, the category ID from the categories table, but only if it doesn't exist. Right? So it's like all this reverse logic, and I know that gets a little bit confusing. But you notice what I did here with spreading out, you know, the subquery. And real frankly, a lot of people might do it kind of like this and put it all on, you know, one line or several lines. So whatever is comfortable for you for looking at it, or maybe they would put the parenthesis up here. There's no like rule as to what the formatting should be. Um, I might write it like that. I might argue that it all can fit on one line just fine, not a big deal. I'm just trying to show you all the different options. I think this will pull back the information that we want. So I'm going to go ahead and cursor's inside the code. I'm running it. And then it pulls back only keyboards. Is this the right output? I have you think about that for a second. That's right. Only the category names that are not in the products table. Now, we did a deep dive and looked at the data before manually. And so we know that's the case. We've already confirmed this. And okay, granted, there's no category 4 here, which is keyboard, right? But this is a super small list, right? This is like 10 products. If you were at, a real music store, like, and I would say, like, go to a real music store someday and look at how many guitars they have, like, on the wall. It might have several hundred, and then you throw in other products, they might have 10,000 products in their store. So this is a very anomalous data set. It's very small data set. But yeah, it's enough, to allow us to look at it and then see basically that the code that we ran is coming back with the correct thing. It is only showing us the category that has nothing. This kind of like, think about it, like the inverse of the first one that we did, in a sense. Everybody okay on this one? It worked okay for you? All right. We're doing kind of okay on time. We might be able to get through all of these. I'm just crossing my fingers. Maybe we can. All right, so let's pull in the instructions for number 4. So here are and I could do block commenting on this. I'm just kind of in this mode now, so I'm not. So I apologize. All right, so this one, it looks like I got to do one more line here. And that is an HTML artifact right there, as is this. All right, it says write a query that displays the product name and the discount percentage from the products table. Use a subquery to make sure only to select those products where the discount percentage is not in the products table, having a count that's greater than 1. Okay, so I guess the first thing I think is helpful, and I'm just kind of saying this is, if you're thinking about the data, like what this even means, in terms of like what data you're trying to extract, rather than just try to write a query and not understand it. So we're ultimately looking to display what information. So when it says displays product name and discount percentage from this table, that kind of gives us our first couple lines of code right there, right? I mean, that's kind of the way that I approach these. So we are going to select the product name and the discount percent from the products table. From products. Okay. You want to alias it? Go for it. All right. Now let's look at the criteria. Okay. So the criteria here is, so for the subquery, so I'm going to do a where clause, right? So where, I'm not sure what I'm looking at. Select only those products where the discount percent, so discount percent is not in, and I'm doing that in bold, so it's in or uppercase because it's uppercase up there, whatever, irrelevant really. Open, close parens, and a semicolon. Right, so I'm going to put my subquery in here. Right, and I'm using this approach, frankly, because I anticipate more than a line or two for this. So only to select the products where the discount percentage is not in the products having a count greater than one. All right. So once again, if you think about what that's saying, we have to still select the discount percent inside of here, right? Because that's what we're kind of focusing on. It's still coming from the same table. So it's still coming from the products table, spelled correctly. All right. And we're looking for it having, so this is where we're using the keyword having instead of where, having a count, right? And that's a function. So what are we counting? How many things have a discount percent, right? That are greater than one. Okay. We're not told to order by or anything like that, but I'm going to tell you I'll show you some modifications I made to mine as I was doing this. Okay, so we get product name, discount percent from products. That's first sentence. The subquery, only where the discount percentage is not in the products having a count that's greater than one. So you see, here's why this is useful, and I want you to think about this. The fact that we can run a query and then by using this not in, we're negating the query and giving us the inverse results to drive our outer query. Where otherwise, you might have to write very different logic to make this happen. I'm going to go ahead and execute this and let's run it and see what our output is. And now I have an error message. So let's figure out what that says. In an aggregated query without group by, the select contains, okay, so what this is telling me is because I'm doing a having statement, right? Or how about like this? If I did a where, would this work? Here's my question for you. Yeah, this is the thought you should have. All right. Well, I'll tell you what. Let's run it and see. Right. It still doesn't work. Invalid use of the group function. So really, what it's looking for is it's looking for grouping. So in other words, having is required, but if we're gonna use having, and if you guys remember this is kind of like refreshing your syntax. We want to group it by the discount percentage so that it will basically conglomerate the results into logical categories. Now, let's try running it now. Here's the run. And then notice that this did give us an output. I'm just going to scroll a little bit here so you can see it. Right, that it shows all the products, right, that are basically not in the table that have a discount greater than 1%. So then why is this one coming up? You know, I'm trying to get you guys to think critically about this. It's counting the discount percents where it's greater than one, but I'm seeing one here that's less than one. Right. What I would say is I would go to the products table and I would look at that one. And I'm not sure why that one's being excluded, right? How many things here, right, if you look at this output, are not in having a count of greater, counting a discount percent that are greater than why am I seeing 5 outputs? It's kind of the question. Anybody think they can verbalize why? Does anybody have a different answer for this one?
How about using star instead of discount percent?
Okay.
Besides, I mean, the fact that there's a 0 there, that doesn't, in my opinion, doesn't make the query wrong, the result wrong, because I think it's not necessarily asking for a value greater than than zero. I mean, as long as there's an entry
Right.
there.
Yeah, and Martin, you're hitting it right, because what are we counting? We're not counting how big the discount is. We're counting how many are how many there are that are more than one. So in other words, how many we're not really even basing it on the discount percent is kind of the point. Analyze the results, but your thinking is correct, right? So we're grouping by discount percentages, but we're looking for a count of how many have a that have a discount, and how many are those? Is this the my question is this the correct output?
I think there was an order by
Okay.
also in the, I
Yeah,
thought,
and in fact, I'm going to do an order by product name, and that is one of the little wrinkles that I threw in last time I did this. I'll run it again. All right, and now we just alphabetized the products. Now, if you read the original instructions again, and I'm just gonna only those products where the discount percentage is not in the products table having a count greater than one. I'm going to let you guys contemplate that for a while. I don't think anybody's kind of seeing what I'm pointing out here. Is this giving us the correct results? Martin, you posited that maybe I could replace this with a wildcard.
no, well, maybe it's the same thing, but in the having count, I thought there was a star there as opposed to, I don't know if that makes any difference whatsoever.
Okay, let's run. Here's what we'll do. We'll run it. Let's look at the output and see if the output is different. It's the same output.
Oh,
Yeah, right. So, I mean, the point of this one really is we're selecting all the things from the products table with a discount percent, but this is really kind of saying the same thing, right? We're doing the count. We could restructure this query in a few different ways to get the same results. Real frankly, what you're seeing on the screen right now, like this, is what I had as my solution the last time I did this. I would say that if you had an asterisk here, that's fine too, and I think it meets the query request. All right, we are, folks, at 7:30, and we have one query left to go. And I think what we'll do with that last one is I'm going to let you guys work on that one on your own, just because we are out of time and I need to kind of switch over to get ready for the other class. What I will do before we adjourn, though, is I'm just going to bring up the instructions here a little bit, and just drop that into my code. And in fact, I actually have it pre-structured over here, so I can just paste it in directly. But this is basically the directive. Write a query that displays the customer's first, last name, email, and then the order ID, and the order date. You'll need to use a subquery for the order date where you select the minimum order date. Okay, so I think that kind of says it right there. If you're not seeing it, like, at least initially, this one will involve a join. So I think what we'll do next time is we'll record a solution for this one that will kind of just append to the beginning of the lecture. Otherwise, you'll be on your own until then to finish this one. And think of it as kind of like a little bit of a challenge exercise here. Now, I will let you know that if you're crafty, you can look on my YouTube channel and find the solution from last year. And I know some of you have figured that out already to help you out. But what I would implore you to do is try to write the code on your own first, and then compare your solution and listen to the explanation and see why it's maybe a little different. All right, folks, this video will end here and solution next week. And I will see you guys next time.